The straight line, lesson 3, and as it happens, take 3. Let's see if this one works. Last year in Nat 5, we were introduced to the general equation of a line, the equation y equals mx plus c. All right, sounds nice and fancy, and for people who don't do maths are thinking, what on earth is this talking about? All right, y equals mx plus c. We saw it in different forms like these ones here. Y equals 7x plus 2. What is this? It's just a rule that connects, for any point on this straight line, a rule that connects the x-coordinate with the y-coordinate. To find the y-coordinate for any x value on the line, do 7 times the x value, add 2. If I tell you what x is, you can work out the y-coordinate, you can plot the point. When you've done that with 2 or 3 points, suddenly you've got a straight line. We saw lines like y equals 3x minus 5. This is of the same form. All right, take away 5, it's the same thing as adding negative 5. It's the same form as the first example here. So is this third one down here, y equals a half x. All right, just because it's a fraction in front of the x, it's just a number multiplying the x, a coefficient. Also, it's got a number on the end. Just because we can't see it doesn't mean it's not there, because it's the same thing as saying plus 0. And we learned last year that the number multiplying the x's coefficient on the x tells me the gradient. It tells me every time I go 1 box horizontally, I go 7 up. For 1 box horizontally, I go 3 up. For 1 unit horizontally, I go half a unit up. And also, if the x-coordinate is 0, in terms of coordinates, along and up, 0 along, I'm only going up. So this is on the y-axis. This is where the line cuts the y-axis. It's known as the y-intercept. Cuts the y-axis, this line, at 0, 2. At 0, negative 5. At 0, 0. If this bit's not there, it's 0. So we said last year, when we've got an equation of the form y equals mx plus c, the coefficient on the x, this m, as we already know, the gradient. The gradient is not mx. The gradient is just the m. And the c is the intercept. Technically, where it cuts the x-axis is also an intercept. So, to be technically correct, we could call this the y-intercept. But to tell the truth, if you're talking about the intercept, almost everyone will understand that we're talking about the y-axis. So you would get away with just talking about the intercept. In the higher exam, if they say give the equation of the line, there are 2 standard forms acceptable, and if you write it in this form, y equals mx plus c, so in other words, that the equation of the line that you resulted in looked like one of these, even without this bit here, that's a perfectly acceptable form of writing it. So to put this into our official notes, all right, here's a point on the line. Any point, so no particular place, with an x-coordinate and a y-coordinate. Remember, label the x and y-axes in your origin. And where it cuts the y-axis here, there's my point 0, c. So it's y equals mx plus c. Also, it's a very handy point using this one if I have to work out the gradient, because change in y over change in x, y2 minus y1 over x2 minus x1, there's a 0 to plug in for my x1. So it just makes it a wee bit simpler. We can use this 2 ways round. If I know the gradient and I know where it cuts the y-axis, I can give the equation of the line. So for example, on this example here, right, equation of the line, there's my intercept. I know it's the intercept because the x-coordinate is 0, so it must be on the y-axis, 0 along. So my intercept, my c, equals 1. Gradient is 6. That's easy then. Y equals 6x plus 1. And we're done. We can also use it the other way around. Okay. If we're given the equation of the line, we can do a quick sketch and we can identify both the gradient and where it cuts the y-axis. Oops, I beg your pardon. So, on example A, y equals 3x plus 1. Immediately, without any working, I can say the gradient must be 3 and the y-intercept is 0, 1. It's because 1y equals, it must be 1y, and everything else must be on the right-hand side of the equals. So on my second example, example B, 2x plus y equals 6. Oh, I don't want this 2x on this side, so I have to subtract 2x from both sides, so I can get the y on its own. Take away 2x from both sides, I get y equals negative 2x plus 6. I'm writing it this way around and not 6 take away 2x because I'm used to the form of y equals mx plus c. Because as soon as I do that, I can see there's my gradient is negative 2. There's my y-intercept. It's at 6, so it's the point 0.06. And finally on my third example, example C, again, it's not in the form y equals, so I need to remove my 3x, and I also have to remove my takeaway 4. So I'm going to subtract 3x. Oh, and to get rid of my takeaway 4, I'm going to add 4 to both sides. So my next line becomes 2y, that's the bit that remains, equals take away 3x when I subtract it from both sides, add 4. But I'm not done yet because it says 2y. And the rule is it must say y equals. So I need to divide everything by 2. And when I divide by 2, every term, this becomes 1y, negative 3 over 2x. Make sure that when you do this, all right, you can put the 2 and the underneath both terms if you want, or just in, I'm putting it in front here just because so it looks more like the y equals mx. Make sure the x is next to the 3, that it doesn't look like it's next to the 2. All right, certainly no lower than the middle. And I'm using a horizontal line here to identify my fraction, not a slash, so that there's no confusion. It does not look like the x is next to the 2. And dividing by 4 by 2 as well gives me my plus 2 on the end. So I can see my gradient is negative 3, 2, and my y-intercept 0, 2. Since, as we said, we can use equations of lines to connect the x-coordinate with the y-coordinate, we can also use it to check out something like this. Does the point 3 minus 1, or 3 negative 1, lie on the line y equals negative 2x plus 4? Indeed, we can use this information that we've just been talking about to see does it lie above or below the line. Here's what we do. We start off with the equation of the line. So the equation of my line, y equals negative 2x plus 4. I'm going to say what would be the y-coordinate that should go with this x-coordinate of 3 if it were to lie on the line. So I'm saying let's pretend it's a line. I'm not going to put in both values. I'm just going to say, using this line, what happens when x is 3? So I'll plug in the 3. So here we are, substituting in 3, y equals negative 2. I put brackets around here so it doesn't look like negative 23. You can use a multiply sign if you prefer. I like this also so that I don't have, if it's a negative number I'm substituting in, I don't have minus 2 times minus, it's a bit clumsy. But it's just my preference. Negative 2, substitute in 3. So negative 2 multiplied by 3, oh, and add on 4. And if I calculate that, negative 2 times 3, negative 6 plus 4 is negative 2. The y point that goes with 3 should be negative 2. In other words, if I did a little sketch of the line down here, if x is 3, let's draw in some little axes. I know the line's going down the way because it's a negative gradient. And I'm saying at this point here where x is 3, the y-coordinate on the line is minus 2. Oh, okay, I should probably have drawn the x-axis up here. But that doesn't really matter. The point is, there's my y-coordinate, negative 2. Oh, but the question said what happens about the point 3, negative 1. Well, the line's got the point 3, negative 2. So 3 minus 1, that's up here. The point is actually above the line. So, the question said, does the point lie on the line? Answer, no, it does not. Because of this working here. Because if it did lie on the line, the y-coordinate should have been negative 2, not negative 1. Okay. That's one standard form for the equation of a line. Y equals mx plus c. Now we're going to have a look at the other one. The second one is this one. ax plus by plus c equals 0. And in this, the numbers a, b, and c are constant figures here. Right? The rule is they cannot be fractions, all right, but have to be integers. For those who've forgotten what integers are or think they've never heard that term before, basically whole numbers, but they can be positive or negative or 0. Also, the coefficient on x, this a term here, conventionally is positive. So I want a positive number on the x and whole numbers all the way through. Doesn't tell me directly the gradient, doesn't tell me the intercept or anything like that. So why do we bother with this? Because this can be used for any line at all, including horizontal and vertical. So if I've got a line like this, y equals 7x plus 2, we were talking about it earlier on. I know the gradient 7, I know the intercept is 2, but how can I set it in this standard form here? Okay, I want everything on the same side, so it's equal to 0, and I want the x term to be positive. Well, the x term is already positive on the right-hand side, so I'm just going to turn the whole thing around. Now I've got my 7x and 2 on the left where I want them. I don't want the y on the right, I want it equal to 0, so I'll subtract y from both sides. So 7x, take away y, plus 2 equals 0. There it is in the second form. So that's equivalent to this one up here. An x term, a y term, plus a number equals 0, no fractions or anything like that, and the x term positive. So that's done. On my second example, y equals negative 5x plus 9. Oh, I'm not going to turn it round because the x has got a negative coefficient in front. I don't want this to say negative 5. My x term should be positive. So this time, a bit like rearranging the subject of a formula, to get my x term on the left, I'm not just going to turn the whole thing round, because if I do, I'll still have negative 5x plus 9 equals y. I'm going to get rid of this negative sign by adding 5x to both sides. So my next line becomes 5x plus y. I've brought my negative 5x over here. While I'm at it, I'll bring the 9 over as well, because I know I want everything on the same side. So instead of add 9, subtract 9 from both sides. So to bring it to the left-hand side of the equals. And now it's equal to 0. Oh, which is what I was wanting. That's in the standard form. So to recap there, if it's a negative term on the x, take it over to the left-hand side without moving the y. But if the x term is positive, like it is up here, all right, then actually I'm going to basically be taking the y over next to there. Although I turned the whole thing around first, just so that I end up with equals 0 on the right-hand side. A third example. What happens if I've got a fraction there? We said earlier you're not allowed fractions. Okay, let's eliminate the fraction first. I don't want, this is the same as saying x over 3. It's 1/3 of x, it's x divided by 3. I don't want it divided by 3, so I'm going to multiply this term by 3. But that means I must multiply every other term by 3. So my next line becomes 3y equals, divide by 3 and multiply by 3. Those things cancel, so I just get x. It's x divided by 3 and multiplied by 3 because I'm multiplying everything by 3. That's why I said multiply by 3, so that this term would disappear. And last but not least, multiply the 4 by 3, so I get 12. Now I need to get everything to the same side. My x term is positive here. Oh, I'll turn the whole thing around. I'm going to say x plus 12 equals 3y. And now I want everything on the left-hand side, so it's equal to 0. X minus 3y plus 12. Again, just putting the y term second, according to convention. and equals 0, which is what I wanted. And last but not least, here's a tricky one because it's got two different fractions in there. Well, let's just get rid of them one at a time. I don't want fifths. Again, make sure the x is on the top half, certainly no lower than the middle. Don't want fifths, don't want halves. I'll get rid of the 5 first. Let's multiply every term through by 5. 5y. If I've cancelled the divide by 5, which is why I'm multiplying by 5, I'm just left with the 3 and the x. Please don't make it something like 15x over 25 and multiply top and bottom. In effect, we're multiplying by 5 means we're multiplying by 5 over 1, because 5 over 1 is the same as 5. Multiplying by 5 over 1, 5 threes are 15 over 5, 15 over 5 is 3. Well, you can go through all that step, but let's just think I'm multiplying by 5, it cancels the divide by 5, they're gone, I'm left with 3x. And likewise here, multiplying this by 5 over 1, all right, if I multiply this by 5, I just multiply the top. There. Now I'm going to get rid of my dividing by 2 here, so I'm going to multiply it by 2, this fraction by 2, which means I multiply everything by 2. 10y equals multiply by 2, 6x minus multiply by 2, cancels the divide by 2, I'm just left with the 5. Now the more astute among you will have said, but wait a minute, could you not just go from the first line straight to the third line by multiplying everything by 10? Because I'm multiplying by 5 and then I'm multiplying by 2. Just multiply everything by 10 and you get straight to the third line. 10y, 3 over 5 times 10, 1/2 times 10. So if you want to do that and just jump straight to the third line, fine, of course you can. Just whichever you're most comfortable and secure with. And then last but not least, I've still not got it in the form I want, so let's just turn it around. I'm going to say 6x minus 5 equals 10y. I'm skipping the line. It's all right, no I'm not. If I wish, I could skip this line here and just immediately pull the 10y into here and jump straight to the line 6x minus 10y to both sides minus 5 equals 0. So if you wish to jump straight from that line to that line again, that's fine. But you must have some working in here. This is the second form that's acceptable to the exam board. Okay, either y equals mx plus c, or an x term and a y term and a number equals 0, no fractions allowed. Okay, so now you get to take a radical step. In your notes, page 8, you can cross out everything on page 8. Because these examples that we've just written down, from example number 2, here's a new general form of a straight line onwards. That replaces page 8. Finally, this, very quickly want to say, there are 6 ways of working out the gradient of a line. We have now covered 5 of them, and the 6th one doesn't come up till into the next topic. Now, some of you are probably panicking, thinking, I can only think of changing y over changing x. Or maybe you can think of 2. So when you wake up in the middle of the night and you're thinking, I can't get back to sleep, why not try, let's recite the 5 of them. Can you pause now and do it? What's the method? If we have y equals mx plus c, the number on the x, so I can rearrange a formula so that it becomes y equals mx plus c. So that's method number 1. Method number 2, well, we've already met it, changing y over changing x. We did that in lesson 1. We also did tan theta, where theta is the angle between the line and the horizontal. That is between the line and the x-axis, or any horizontal line. Tan of that angle gives you the gradient. Third way, we know if the 2 lines are parallel, they have the same gradient. And we know if they are perpendicular, the two gradients must multiply to be -1. Sorry, that was numbers 4 and 5. So, change the line to y equals mx plus c. Changing y for changing x, or if you prefer, y2 minus y1 over x2 minus x1. Tan theta, parallel lines, perpendicular lines. If two lines are perpendicular, the two gradients multiply to be -1. And so basically to get the second one, the shortcut is turn the first gradient upside down and swap the sign. And that's the end of this lesson.